All right, so this is the key to worksheet number 8. And you can't see this very well, but that's an open circle. So that means composition. That means composition. So you're composing these two functions and you're evaluating it at 3. You're composing these two functions, evaluating at -1, and so on. You're composing these two functions, evaluating it at x, and composing these two functions and evaluating it at x. All right, so remember, composition means you take one function, put it inside of another function, okay? Means something totally different than the other worksheet you did where you were adding. So adding, you're just adding two functions together. You're subtracting two functions from each other. You're multiplying two functions. Whereas with composition, when you have that open circle, you're actually taking a function, putting it inside of another. Now notice this is an open circle. This is a closed circle. So remember, closed circle means multiplication. So this is multiplication right here. This is composition. Okay? So composition. So you're composing functions. So composition. All right, so let's look at number 1. So here's number 1. So number 1, you have f composed with g evaluated at 3. That's 3, not x. That's 3. All right, so by definition, this is what this means. So you got to remember your notation. By definition, this means f of g of 3. That's what that means. So f of g of 3. So just kind of see this right here, and then that should be in this little area here. And then you're taking, so remember what I said, composition, you're taking a function, put it inside of another. So you're going to take g of 3, and you're going to put it inside of f. So notice f is listed first, f is listed first. G is listed second, g is listed second. Okay, so that's your definition. All right, now what you have to do now is do the inside first. So we got to go off to the side, and we have to figure out what g of 3 is. Okay, so that's what I need to do first, figure out what g of 3 is. Well, to figure out what g of 3 is, I need to first of all determine what my function g is. So I got to determine what g of x is. Well, g of x is 7x minus 3. So I'm going to go ahead and write that out, 7x minus 3. So you've learned this before. So to find g of 3, where we see the function, you're going to go to your function g of x, and where we see the variable x, you're going to substitute 3. So this becomes, g of 3 becomes 7 times 3 minus 3. Well, 7 times 3 is 21, and then 21 subtract 3 is going to be 18. Okay, so that's g of 3. So now I'm going to come back here, because now I know what this is. G of 3 is now 18. So this has become f of 18. And to find f of 18, I'm going to go to my function f of x, which is negative 4x plus 7. And where we see the variable x, I'm going to substitute 18. So this becomes negative 4 times 18. Negative 4 times x. X is 18, so negative 4 times 18, and then plus 7. Using the order of operations, negative 4 times 18, so use your calculator if you have to. Negative 4 times 18 is going to be a negative 72. And then plus 7. And then negative 72 plus 7, use your calculator if you have to, is going to be a negative 65. So the answer is negative 65. So f composed with g at 3 is a negative 65. Okay, number 2. Number 2, we have h composed with f at -1. Same idea, same definition. So this is composition, that's not multiplication. That's composition. So I'm going to have to determine what f of -1 is first, and then whatever that is, I'm going to put into my function g. So by definition, this means h of f of -1. So make sure you read it like that. H of f of -1. Okay? That's the way it needs to look. That's your definition. Then, just like before, I'm going to figure out the innermost function first. So that's f of -1. And to determine f of -1, I have to go to my function f of x. So remember, this is f of x. F of x is negative 4x plus 7. So in place of x, I'm going to substitute -1. That's what this tells me to do. So f of negative 1 then will be negative 4 times negative 1 plus 7. Multiplication before you add, order of operations. Negative 4 times negative 1 is a positive 4. 4 plus 7 is going to be 11. So that's what f of negative 1 is. So this becomes h of 11. So then this means, well, I need to go to my function h of x. And so h of x is 3x squared plus 5x minus 7. So remember, that's what h of x is right here. And in place of x, which I see it listed twice, I'm going to substitute 11. So this becomes 3 times 11 squared plus 5 times 11 minus 7. So 3 times 11 squared plus 5 times 11 minus 7. All right, so now we got to do the order of operations. So I'm going to have to do exponents before I multiply. So don't say 3 times 11 is 33 and then square it. Order of operations. You have to do exponents, then multiplication. So this becomes 3 times, and then 11 times 11 is 121, but if you didn't remember it, just use your calculator. 11 squared is 121. And then 5 times 11 is 55 minus 7. Okay, 3 times 121, so times 3 is 363. So I get 363 plus 55 minus 7. So let's go ahead and add and subtract. So 363 plus 55 minus 7 equals 411. All right, so H composed with F at negative 1 is equal to 411. All right, so that's number 2. All right, number 3. So this time in number 3, so notice, before I go to number 3, notice I was composing two functions and evaluating it at a number. See, a number. So I ended up with the answer being a number. Composing two functions at a number. My answer was a number. Now, I guess I should say numerical value. But when I do number 3, notice number 3, this time I'm composing two functions at the variable x. So that's not a number. That's a variable. My answer is going to be a variable expression. It's not going to be a number. It's going to be a variable expression. So let's go ahead and write the definition. By definition, this means g of f of x. That's what that means. So notice the difference between this and this. See? The definition is the same, except this was g of 3 because that's what I was evaluating it at, and this was f of x because that's what I'm evaluating it at. I'm evaluating it at the variable x. All right, so just as we did before, I got to look at this one first. So f of x is equal to negative 4x plus 7. So so notice in the previous one, I could actually evaluate it, right? G of 3. So in place of x, I substitute 3, ended up with a number. Here, though, there's nothing to substitute. You're just told, well, what is f of x? Well, f of x is this. So in place of f of x, I'm going to substitute this expression right here. So now this becomes g of negative 4x plus 7. Then what that means, just like what this meant when I went back here, to find f of 18, I had to go to my function f, and wherever I saw the variable, I had to substitute 18. Well, same thing here. I'm going to go to my function g, which is 7x minus 3. So g of x is 7x minus 3. And wherever I see that variable, I'm going to substitute negative 4x plus 7. So you're going to substitute that. So this becomes 7 times x, but in place of x, I'm substituting this expression, negative 4x plus 7. And then I'm going to subtract 3. So now let's go ahead and use the distributive property. 7 times negative 4x is a negative 28x. 7 times 7 is a positive 49, and then subtract 3. Combining like terms, I get negative 28x. Positive 49 and a negative 3 is a positive 46. And so there's your answer. So notice a variable expression. Whereas in the first two, when I was evaluating these compositions at a number, I ended up with numbers as the answer. Here I end up with a variable expression. So G composed with F at x is equal to negative 28x plus 46. All right, number 4, you want to find H composed with G at x. All right, so by definition, this becomes H of G of x. So then I got to figure out what G of x is. Well, G of x is 7x minus 3. So G of x is 7x minus 3. So what that means is that I'm going to now replace G of x with this expression right here. So that becomes H of 7x minus 3. Now, remember what that means, just like we did this one here. So this says I go to my function h, which is this quadratic function, 3x squared plus 5x minus 7. So h of x is 3x squared plus 5x minus 7. And wherever I see that variable, I'm going to substitute 7x minus 3. So this becomes, so I'm going to substitute wherever I see the variable x, I'm going to substitute 7x minus 3. So this becomes 3 times 7x minus 3 squared plus 5 times 7x minus 3. So wherever I see the variable x, I substitute 7x minus 3, and then minus 7. Okay, so now I've got to get rid of the parentheses. Notice this parentheses here is being squared. This parentheses here is being raised to the first power. So here, since that's a 1 right here, I can use the distributive property. But I can't use the distributive property here because the order of operations says I have to do exponents first. So let's figure out what 7x minus 3 squared is. I'm going to go ahead and do it over here. So 7x minus 3 squared means 7x minus 3 times itself. So notice I'm multiplying two binomials, so I can use the fall method. First times first, 7x times 7x is 49x squared. The outer, 7x times a negative 3 is a negative 21x. Now remember, whenever you square a binomial, the out and the inner are going to be identical. So if this is 21x, then the inner needs to be negative 21x also. Negative 3 times 7x, negative 21x. And then the last, a negative 3 times a negative 3 is a positive 9. Combining like terms, I get 49x squared. A negative 21x and a negative 21x is a negative 42x, and then plus 9. So that is just this. So this becomes 3 times 49x squared minus 42x plus 9. And then let's go ahead and distribute this one. So 5 times 7x is 35x. 5 times negative 3 is a negative 15, and then minus 7. Okay, using distributive property. Now I can use the distributive property here because that's a 1. So 3 times 49x, use your calculator. 49 times 3 is 147. So that's 147x squared. 3 times 42, so 3 times 42 is 126. So 3 times a negative 42x is a negative 126x, and then 3 times a positive 9 is a positive 27. And I'm going to just go ahead and rewrite all this other stuff up, down. 35x minus 15 minus 7. All right, let's combine like terms. So I have 147x squared. Okay, now negative 126x, and I can combine that with a positive 35x. So use your calculator if you have to. So negative 126 plus 35 equals a negative 91. So negative 126x and a positive 35x is a negative 91x. All right, now 27, subtract 15, subtract 7. Those are your constants. So 27, subtract 15, subtract 7 equals a positive 5. And there's your answer. So H composed with G at x is going to equal this trinomial. So 147x squared minus 91x plus 5. All right, so that's composition. So that's how you deal with composition. So composition is where you take one function, put it inside another. So that's what we've been doing. All right, so that is it. So that is the key to um, functions worksheet number 8.